Okay, let's look at your drawings that you're going to create. And I give you lots of information in Blackboard about the drawings. You're going to be creating detailed drawings for parts 1, 2, 3, 5, 6, 7, and 8. And then a section assembly drawing. And in the DWIF file, which I have open right here, there's samples of all the layout sheets. So I'm not going to show you how to set up all of these. You can figure those out. Okay. Here's part number 1. This is a left side view, but it has been cropped. Okay. When you dimension an ellipse, because this is lofted, you only dimension the width of it, because no matter where you are height-wise on this thing, the length of the ellipse will change. So just dimension the width of it. Keyway, this is the keyway view here, so that's where the keyway is dimensioned. Because over here it's on the opposite side of the object, and you don't want to dimension things on the opposite side. All right, so think carefully of where you're going to place your dimensions for this one. Okay, part number 2, not a lot to say. It's a full section. Most of your dimensions should go in the section view, and they are linear diameter dimensions, remember? Maybe, okay, yeah, let me, I'll demonstrate doing projected intersections. So I'll show you how to do that in case you may have forgotten. We'll review that. Okay, so here in this sheet for part number 5, we want a top view showing things, so you can dimension this hole and the lengths of, well, not the lengths of the keyway, but we're putting a section in it so that we can see the side view of it there. And mainly, a lot of that is just detail. Sorry, here's our section down here. I don't know what I was thinking. Here's our section, so you can dimension this keyway slot and refer to the book on how to dimension that. Okay. And then the Woodruff key itself, we're going to place in here, and you will dimension the Woodruff key itself. Okay. As shown in the textbook. Okay. And this end of our object, there's a note in the textbook about that, the thread, the 1/8 American Standard pipe tap for a Bowen grease cup T-76-00. That entire note needs to go here along with the depth of the hole. So do not dimension the depth of the hole up here in this view. That is incorrect. You can edit, well, if you do a hole note, it will pick up the thread diameter and the depth. You add the depth of the hole. And then you just add a note below it about the Bowen grease cup and the part number for that. Okay. The bushing, we get a front view, end view, and a full section. And do not use a leader to tell me the size of these oil grooves. Actually dimension them, please. Okay. Because if you just use a leader with text, it leaves too much to be interpreted by the machinist. And we don't want him to have to think about it. We just want him to know exactly what dimensions we're getting. Okay. All right. So let me go to Inventor here, to a drawing. And I'll start with the let me locate the wheel and bring it in, and I will show you what I'm talking about with projected intersections. Come on. Well, that is not the view that I have wanted. What am I doing? I'm not even thinking. So let me, I see now. And now I'll do a section. Okay, so dimensioning, because we want pretty much like what is shown in the textbook. This one will be the easiest. So I'm going to click that line, then right click and go intersection and click this line, and then come out. And let me try one thing here. If I put a center line in first, now let me try a limit. I'm experimenting here. No, okay, I can't do a linear diameter and an intersection at the same time. So what we'll have to manually go intersection and then come down and hit that one again and right click and go intersection again. And then you can place it. I'm just curious. Linear diameter. Woo, that went too much. Okay, we'll just do it manually. Be the easiest way. So that right click intersection there. This right click intersection and there. And that gives you what that would be before fillets were applied. And for this one right here, you can choose that edge, intersection, and the outside edge. Okay, and so most of your diameter dimensions are going to be in the section view. Okay, because that's why we got the section view there for. So that's where they should be. All right, so now let's look at the assembly. And I'm going to bring in a base view of this, but I want to bring in the top. And I want to go ahead and make it a hidden line and set my scale 1 to 1. And let's see, display options. I want to turn on thread features because we have threaded objects in here. Now this is a very confusing view. And so we're going to move it up here out of the way. And there's a couple of different ways that you can do assembly sections. Here you can put a view in and then section that view and pull it down. Or in your assembly, you can create a section view and save it as a model state and then bring that in. I find this to be the least confusing. It may be the most unorthodox though, but we'll see. So I select the view, put my cutting plane in, pull my section view down, and get it placed, and then I can move this view off of the sheet. course, I have to use it to drag, but that's okay. Now, a couple of things here. Since we have different material types, we're changing the hatch patterns. And so you just highlight the hatch pattern, double click, and then you'll change it. Okay. And the patterns are in the textbook, page 336. So you want to change everything based on material. Okay. Remember, fasteners are not sectioned, so the hex nut is not going to be sectioned. The Woodruff key is not sectioned. This shaft, it could go either way, but we're going to go ahead and section it because we got lots of detail here that we need to show. Now, these screws down here should not be sectioned, but because they're a custom part that we created, Inventor doesn't know what to do with it. So over here in your properties, here in the section view, okay, so expand that and then expand your assembly and go down to those parts right here. Right click that part and go section participation and set that to none. Wow, isn't that sweet? Okay. Look at my notes here. Okay, that's looking good. So you'll make the change to that one also. Change your material types for these phosphorus bronze thingies. And then do balloons around. Okay. And then a parts list. Select my view. Okay. And I'll drop my parts list in. And you can see now, if you followed the note I put in Blackboard instead of what I said in the videos, the description will come in. But we do want to edit that and add our material column. And with these, we'll adjust the width of some of these. Whoa, that's not what I wanted. Let me back that up and get me down to a single line. There we go. That'll work right there. We do want to adjust the bronze, because that should say loss. I don't remember how to spell it, so I'm going to just go with the textbook. The steel, let's see. That's fine for the key. That came from over. The shaft is it's a cold rolled steel. And it gets a heat treat 0. Or O. Okay, phosphorus bronze, cast iron, phosphorus bronze. The screw is machined steel. Okay, so that's fine there, the high strength low alloy. That's fine. Okay. And so that's got a lot of that. Of course, fill in the title block information. You're going to have all your balloons around here, and that'll look good on that part. We are going to work with some tolerances on this, and I will come back with another video on setting up tolerances for your detailed drawings.